Hey subscribers, today we are going to be working on this question for Leah. This is a calculator question to do with volume, area. I think there might be some trigonometry involved with this. So let's get started with it. First thing, let's read it. So cross-section, this is a cross-section of a container, which is a semicircle. So in other words, the actual shape we're looking at kind of looks like this. It's a three-dimensional shape that's been filled with water to a certain level. And we can see the cross-section of it. The length of the container is 20 centimeters. So that you can't see on the diagram, but that's going to be 20 centimeters. And then the 12 is basically that distance. It's the diameter if it was a full circle, and the depth is 4 centimeters. Calculate the number of liters of water in the container. Right, so first of all, what we need to do is figure out how we can break this down into shapes that we know. Shapes that we might know here. Obviously, this shape here is it's not a standard sector. So when you have a circle and you're expected to work out the area of a sector, that's fairly straightforward if you have the angle. Problem here is this is basically kind of like, well, if this was a sector here, we're actually being asked to work out some fraction of it, and it's not the same as a normal sector. It isn't the sector. So what we can potentially do here is make it into a sector. So you've got this shape here. It's not very well drawn by me, but you can see that's the sector we're looking at here. And then we can just take away this green bit, which is a triangle, because the grey area we can't work out directly. So we want to work out the purple area, take away the green area. In order to do that, we need some measurements, so let's figure those out first. So what we can say is, if that is 12, then obviously the radius was 6. So that means this distance here has to be 6, which also means this distance here is also 6. Now if that's 4, then that's going to be 2. So we're going to label that a bit neater. I'm just going to call that 2 centimeters. That's this height here. We know that this distance here, we don't know actually, so let's ignore that for a second. What we can work out though is the distance from the center to that point. That is also the radius, so that will also be 6 centimeters. That's 2 centimeters. Now we can work out that distance just using basic Pythagoras. So let's just sketch the shape out. If the hypotenuse is 6, the height of this triangle is 2, and x is what we want to work out. We can say x squared plus 2 squared equals 6 squared. X squared equals 6 squared minus 2 squared, which is 36 minus 4. And then we're going to square root that, so x is equal to the square root of 32. Let's leave that as a square root for now. So square root of 32 just becomes 4 root 2. So let's label that as 4 root 2. So x equals 4 root 2. Now we want to work out the sector. So let's do this in green. The sector we want is this distance, which we know is 6 centimeters. This distance is obviously also 6 centimeters, but this angle we don't have. And that is something we're going to need to work out. So let's go back to this triangle and work out this angle here. We'll call it theta. So we've actually got all three sides, so we can use whichever SOHCAHTOA we want to because it's a right angle triangle. So let's just say we're going to use sine just for giggles. So sine theta equals O over H. Sine theta equals, well, opposite here would be 4 root 2. So 4 root 2 over the hypotenuse, which is 6. and then theta equals sine inverse of 4 root 2 over 6. So I'm just going to pull up the calculator. Okay, so we're going to shift sine and then fraction 4 root 2 over 6, close brackets. The angle turns out to be 70.52877. So theta equals 70.52877, and that's rounded enough. So we won't round it more than that. Technically, I know that should perhaps be an 8 at the end. It doesn't make a difference after 4 decimal places, though. So we now have the angle. Now, the formula for area of a sector is just area of a circle, pi r squared, times theta, because it's a fraction, theta over 360. That theta is 70.52, so we're just going to do pi r squared, radius is 6, theta is 70 point blah blah blah. So let's put that in the calculator. Shift pi times radius, which is 6 squared. So you can just put 36 in straight away, times pi r squared times fraction. And then I've actually got the answer from before, so I'm going to press answer over 360. So pi times 36 times answer over 360. Otherwise, I would have put 70.52877 over 360, and I get 22.1572. So the area of the sector, this whole sector here, is 70, as it showed on the calculator. 22.1572. 22.1572. I'll put an extra few decimals just because your answer will be off if you round it too much early on. So that's the area of the whole sector. Now we need to find the area of the triangle, because we're going to take away this little purple triangle from the green sector. So area of the triangle, half times base times height, so equals half times base is 4 root 2 times height, which is 2. So that is just going to be 4 root 2. So the area is equal to 4 root 2 units squared, or centimeters squared in this case. So we're going to take the purple area away from the green area. So that will be, so we've already got that on our calculator, so I'm going to do answer take away 4 root 2. That gives me 16.5004. Now, this is the grey area that we want, this bit, this grey area. I'll colour it in orange. This is the area we've just worked out. Obviously, we've got 2 of those. So we're going to times the answer by 2. So answer times 2. 33, almost exactly. So it's actually quite well rounded. So here we can say the orange area equals 33.000, I think it was 0.00083053. So that is the area of the grey bit. Now we need to multiply it by the depth. The depth is 20. So we're just going to simply multiply it by 20. Double check the units. edXL love messing with units here, so just make sure they match. So now answer times 20, and that will give us 660.01. So 660.01659 centimeters squared. Calculate the number of liters of water. So now we need to convert from centimeters, that should be centimeter, that's the volume, so that should be centimeters cubed. So we're going to convert from centimeters cubed into liters. We're going to divide by 1,000. check your conversion units if you need to revise that. I'm not going to go through that bit, but you basically get 0.660169, and it says to two significant figures, so 0.66. So that rounds to 0.66 litres. That is how you do that question. Make sure to smash the like button, hit subscribe, and there'll be more content for you guys later. Thank you for watching.